Hey there, future computer whizzes! Ever wonder how computers think? Well, they don't think like you and me, but they are super fast at following instructions. Deep down inside, computers use electricity to do their magic. Think of it like a light switch. It's either on or off, right? Computers use a similar system, but instead of on and off, they use 1 and 0. This is called binary code, a secret language for computers. Everything a computer does, from showing pictures to playing games, boils down to these ones and zeros zipping around inside. Cool, huh? Now, let's talk about transistors. These tiny things are like the superheroes of the computer world. They control the flow of electricity, just like that light switch we talked about. Imagine a transistor as a tiny gate. When the gate is open, electricity flows through, representing a 1. When the gate is closed, no electricity flows, representing a 0. These transistors are super small. Millions can fit on a chip the size of your fingernail. By turning on and off really fast, transistors help computers process information at lightning speed. Now hold on to your hats. We're going deeper into the computer. Remember those transistors? Well, they team up to form something called logic gates. Think of logic gates like building blocks. Each block has a special rule. For example, one type of gate might say, if both inputs are 1, then the output is 1. Otherwise, it's 0. By connecting lots of these logic gates, we can build circuits that perform more complex tasks, like adding numbers or comparing values. It's like building with Legos, but instead of cool spaceships, we're building the brains of a computer. Now let's meet the boss, the CPU, or Central Processing Unit. This tiny but mighty component is the heart and soul of your computer, orchestrating every operation and ensuring everything runs smoothly. This is the brain of the computer, where all the thinking happens. Just like our brains process thoughts and actions, the CPU processes all the instructions it receives from software and hardware. Inside the CPU, we have a few important parts, each with its own unique role. These parts work together in harmony to execute complex tasks at lightning speed. The ALU, or Arithmetic Logic Unit, is like the math whiz. It's responsible for performing all arithmetic and logical operations. Whether it's simple addition or complex algorithms, the ALU handles it all with precision. It handles all the calculations, like adding, subtracting, and comparing numbers. Imagine it as the calculator of the CPU, tirelessly crunching numbers to keep everything in check. Registers are like tiny storage boxes that hold the data the CPU is working on. These small but fast storage locations temporarily hold data and instructions that the CPU needs right away. The control unit is the manager, telling all the other parts what to do and when to do it. It directs the flow of data and instructions within the CPU, ensuring everything happens in the right order. And the clock sets the speed at which the CPU operates, ticking billions of times per second. This clock ensures that all operations are synchronized and executed at the right pace. The CPU takes instructions from the software and uses its different parts to get the job done. It decodes these instructions and executes them, making sure your computer performs tasks efficiently. It's like a well-oiled machine, working tirelessly to run your favorite games and apps. Whether you're gaming, streaming, or working, the CPU is always at the heart of the action, ensuring everything runs seamlessly. Section 5, Speaking Computer Language. It's all 1S and 0S. We've talked about 1s and 0s, but how does the computer actually understand them? This is where machine language comes in. It's a special code made up entirely of, you guessed it, 1s and 0s. Each sequence of 1s and 0s represents a specific instruction for the CPU. The CPU follows a cycle. Fetch. Grab the next instruction from memory. Decode. Figure out what the instruction means. Execute. Carry out the instruction. This cycle repeats billions of times per second, allowing the CPU to process information and run programs incredibly fast. Section 6, the memory bank, where information hangs out. Computers need to remember things, right? Just like our brains, computers have their own way of storing and recalling information. This is essential for them to function properly and efficiently. That's where memory comes in. Memory in a computer is a critical component that allows it to perform tasks, run applications, and store data. There are different types of memory, each serving a unique purpose. Understanding these types can help us appreciate how computers manage to do so much so quickly. RAM, or random access memory, is like the computer's short-term memory. It temporarily holds data that the computer is actively using so that it can be accessed quickly. It stores data that the CPU needs to access quickly. This makes it possible for your computer to run multiple applications at the same time without slowing down. When you turn off the computer, RAM forgets everything. This is why unsaved work can be lost if your computer shuts down unexpectedly. Cache is even faster than RAM. It's a smaller but much quicker type of memory that stores frequently accessed data to speed up processing times. It stores frequently used data so the CPU can access it super fast. This helps in reducing the time it takes to retrieve data, making your computer feel more responsive. HDD or SSD, hard disk drive or solid-state drive, is the computer's long-term memory. Unlike RAM, this type of memory retains information even when the computer is turned off. It stores all your files, even when the computer is turned off. This includes your documents, photos, videos, and software applications. Each type of memory plays a crucial role in keeping the computer running smoothly and storing all your important information. By working together, they ensure that your computer can handle everything from simple tasks to complex operations efficiently. Section 7. Talking to computers, input and output magic. How do we communicate with computers? Through input and output devices. Input devices allow us to send information to the computer. Think keyboards, mice, microphones, and even touchscreens. Output devices allow the computer to send information back to us. Think monitors, speakers, and printers. When you press a key on the keyboard, it sends a signal to the CPU, which processes it and displays the corresponding letter on the screen. It's like a conversation between you and the computer. Section 8. The computer's boss, the operating system. Ever wonder who keeps all those different parts of the computer working together? That's the operating system, or OS for short. The OS is like the computer's boss, managing everything from memory to input and output devices. It also provides a platform for running all your favorite software, like games, apps, and web browsers. Popular operating systems include Windows, macOS, and Linux. They all do the same basic job, but each has its own unique look and feel. Section 9. From key press to screen. A journey through the computer. In this section, we will explore the fascinating journey that takes place inside your computer every time you press a key. It's a complex process, but we'll break it down step by step to make it easy to understand. Let's recap everything with an example. This will help us see the entire process in action and understand how each component of the computer works together seamlessly. Imagine you're playing a game and you press the spacebar to make your character jump. This simple action sets off a chain reaction inside your computer. Here's what happens. The keyboard sends a signal to the CPU, indicating that the spacebar has been pressed. This signal is an electrical impulse that travels through the keyboard's circuitry. The CPU receives the signal and checks the game's instructions. The CPU, or Central Processing Unit, is often referred to as the brain of the computer. It processes the signal and determines what action needs to be taken based on the game's code. The CPU instructs the graphics card to change the character's position on the screen, making it jump. The graphics card, also known as the GPU, is responsible for rendering images and animations. It takes the instructions from the CPU and updates the game's graphics accordingly. The updated image is sent to the monitor, and you see your character jump. Amazing, right? This entire process happens almost instantaneously, giving you a smooth and responsive gaming experience. All of that happens in the blink of an eye, thanks to the magic of electricity, transistors, logic gates, and all the other amazing components that make up a computer. These tiny components work together to perform complex calculations and processes at incredible speeds. So there you have it, a whirlwind tour of how computers work. From the moment you press a key to the instant you see the result on your screen, it's a journey through a world of technology and innovation. Now you know that behind all the screens and buttons, it all comes down to those amazing ones and zeros. Binary code is the fundamental language of computers, and it's what allows them to perform all their incredible tasks. Keep exploring, keep asking questions, and who knows? The world of computers is vast and full of possibilities. There's always something new to learn and discover. Maybe you'll be the one building the next generation of supercomputers. The future of technology is in your hands, and with curiosity and determination, you can achieve